GATE 2018 Civil Engineering Set 2 Question 42. A cable PQ of length 25 meter is supported at two ends at the same level as shown in the figure. The horizontal distance between the supports is 20 meter as shown in the figure. A point load of 150 kN is applied at point R, which divides it into two equal parts. Neglecting the self weight of the cable, the tension in the cable due to the applied load will be. The answer needs to be found in kilonewton and should be a integer value. The relevant NPTEL reference has been cited. When it comes to analyzing a symmetric cable which has supports at the same level, it will generally be used to carry a certain load W. So in that case, if we need to determine the tension, due to its symmetry, what happens is the tension in both the cables remains the same. In case it was not symmetric, the tensions may have been different. But here, if we assume the system to be symmetric, the tensions will be the same. Here we can see that if we take this point X and want it to be at equilibrium, so the horizontal force should be summed up to 0. This would give T1 sin theta 1 equals T2 sin theta 2. Similarly, the sum of all the vertical forces at the point X should be 0. Using this, we would get T1 cos theta 1 plus T2 cos theta 2 should be equal to the downward load acting on the cable at that point, that is W. This may contain the self weight or may not contain, depending upon the question. In the given question, it has been given that the overall length of the cable is 25 meters. This essentially means that this segment of the cable PR will be 12.5 meters and QR would be 12.5 meters. If we connect P and Q and connect this with R, it will form a right angle triangle where this line will be 10 meters and this would be 10 meters. Let us call this point as O and this height OR as H. So H can be found out as square root of 12.5 square minus 10 square using the right angle triangle principle. This would give the value to be the square root of 56.25, which would turn out to be 7.5 meters. Now to find the tension in the cable, since this is a symmetric system, we can assume the tension in both cables will be same, which is T and T. The angles will also remain the same, theta and theta. To do the vertical forces summation 0, we take T cos theta from the left in the cable PR and T cos theta from the right in the cable RQ and equate this to the net downward load, that is 150 kilonewton in this case. This would give 2T cos theta as 150 kilonewton. Here we can see that cos theta will be base by hypotenuse. So base is H and hypotenuse is 12.5. H was found out to be 7.5 by 12.5. This would give the value to be 0.6. Substituting the values, we would get T equals 150 divided by 2 into 0.6. The value would be 125 kilonewton in each cable. So the tension in kilonewtons in the cable due to the applied load will be 125 kilonewtons. The relevant NPTEL reference has been cited.